All right, gather round, you digital denizens, for another installment of humanity's ceaseless quest to automate every last thought and image out of its collective brain. Today, we're dissecting the grand ambitions of what they've dubbed the Setsin Tak AI News Transcript Generator, a title that promises chaos and delivers, well, algorithms. We're plunging headfirst into the abyss of text-to-image customization, from the ominously named LyCORIS fine-tuning to the existential dread of model evaluation. And let me tell you, it's about as thrilling as watching paint dry if the paint was sentient and constantly judging your life choices. The core problem, you see, is that these so-called generative models, your Stable Diffusions, your DALL-Es, the entire digital menagerie, they've gotten quite good at conjuring high-fidelity images from mere text prompts. But the moment you want something specific, something personal, like a photo of your cat wearing a tiny top hat while riding a unicycle made of cheese, that's when the intricacies of fine-tuning descend like a legion of paperclips in a recursive nightmare. It's a multifaceted hydra of new methodologies, systematic evaluation, and the sheer, unadulterated challenge of telling a machine what you want without accidentally summoning Cthulhu in a tutu. This paper, in its infinite wisdom, throws us a lifeline like LyCORIS, LoRA beyond conventional methods, other rank adaptation implementations for Stable Diffusion. Catchy, isn't it? Sounds less like a library and more like a secret government project to weaponize abstract art. The objective? To serve as a test bed. Because nothing says cutting-edge research like a digital sandbox where we meticulously catalog our failures. We'll simplify this jargon, not out of kindness, but out of necessity, because even fool sometimes struggle to stomach the sheer volume of acronyms. First, let's talk about the bedrock of this digital alchemy, Stable Diffusion. Imagine, if you will, teaching a toddler to paint by showing it enough chaotic static until it accidentally creates a masterpiece. That's essentially what diffusion models do. You give them an initial noise map, basically a digital scramble of TV static, and they iteratively refine it, slowly reversing the diffusion process until it magically transforms into a desired image. It's all done in a latent space, which sounds far more profound than it is. Think of it as a dimly lit, infinitely vast digital attic, where images are stored as abstract concepts before being fleshed out. The magic happens via a denoising UNet, a neural network so named because its architecture vaguely resembles the letter U, which is as profound as its function, honestly, and a text encoder that translates your whimsical prompts into something the UNet can actually understand. We're talking about minimizing a loss function, which is just a fancy way of saying we're teaching the AI to hate its own mistakes until it stops making them. Now, personalizing this digital beast, that's where model customization slithers in, often leveraging something called LoRA, or low-rank adaptation. LoRA, the digital equivalent of a diet for large language models, later adapted for our image-generating friends. It's designed to substantially reduce the number of parameters you need to update. Think of it this way: instead of resculpting the entire colossal clay golem that is Stable Diffusion, you just attach a tiny low-rank matrix, a sort of digital plastic surgery. Behold imageer1.png. It looks less like a neural network and more like an ant colony diligently constructing a surprisingly elaborate underground city, each worker meticulously adding its minuscule contribution to the grand design. See those frozen pre-trained weights, WO. That's the immovable, established foundation, the colossal marble statue that cannot be touched. But the magical EW, the weight update, that's factored into two much smaller low-rank matrices, B and A. It's like the creamy, flexible middle of an Oreo, small, swappable, and powerful without touching the whole cookie. You don't retrain the whole brain, you just add a new, tiny, specialized lobe. The LyCORIS library builds upon this LoRA initiative, offering a buffet of fine-tuning strategies. Its design and objectives are predictably to be a test bed for experimentation, seamlessly integrating with existing tools. It lets you scale and combine weight updates like digital Lego bricks. Among its implemented algorithms, we primarily focus on LoRA, which here means LoCON or low-rank convolution, LoHa and LoKr. LoCON extends the low-rank adapter to the convolutional layers of diffusion models, because apparently the attention layers weren't suffering enough. The intuition, more layers involved, better performance. Shocking, I know. Then there's LoHa. Inspired by LoRA, it seeks to enhance fine-tuning by mitigating the low-rank constraint. It's like fitting more clowns into the same car, purely for the sake of wrong. It uses a Hadamard product, element-wise multiplication, on two sets of low-rank matrices. This allows the resulting matrix to have a higher rank, a measure of its complexity or expressiveness with the same number of trainable parameters. It's more expressive, more nuanced, ostensibly better. And then LoKr, low-rank adaptation with Kronecker product. If LoHa is about fitting more clowns, LoKr is about fitting more dimensions into the clown car. It extends the Krone technique, using Kronecker products for matrix decomposition. This has a multiplicative nature of their ranks, allowing us to move beyond the limitations of low-rank assumptions. A unique advantage, apparently, that allows for the smallest file sizes. The minimalist dream, or perhaps a secret society's encryption method. You can represent its AEH transformation ZCEBA as a sequence of 3 linear layers. Gaze upon image under 7.png. This diagram illustrates the terrifying elegance of it all. Data flows through layers represented by boxes with dimensions. Vectors EH become H, transformed by matrices AA, EEB, and SC through operations that resemble the arcane symbols of a forgotten cult. It's a hierarchical processing of information, a digital meat grinder for data representations, ultimately leading to a more refined output, or, a smaller file. Beyond these, LyCORIS has already incorporated other equally thrilling acronyms like DILORA, GLORA, and IA3, with OFT, BOFT, and DORA joining the party since the paper's submission. It's an endless parade of increasingly specific ways to tweak the digital beast. Now, with all these algorithmic choices, one naturally wonders, is there an optimal way to fine-tune Stable Diffusion, or are we just throwing digital spaghetti at the wall to see what sticks? To answer this, we need systematic assessment, because apparently throwing spaghetti at the wall and calling it art wasn't rigorous enough. This brings us to model evaluation, a labyrinth of prompt classifications and arbitrary criteria. We categorize prompts, training prompts, what it should know, generalization prompts, what we hopic it knows beyond its miserable training data, and concept-agnostic prompts, what we pray it doesn't know, lest it accidentally leak the horrifying truths of its digital subconscious. Then, the evaluation criteria themselves. Bull fidelity. Does the generated image actually resemble the target concept, or did it just produce a blurry approximation of your existential dread? For controllability, can the model actually follow your absurd textual commands, or does it just shrug its digital shoulders and generate another cat in a top hat, but sideways? Fuck diversity shit. Does it produce a variety of images, or just 100 slightly different versions of that one regrettable vacation photo? Fucking fuck-base model preservation. How much does fine-tuning accidentally fucking break the original model? Because who wants to train a model to draw a perfect top hat only to find it's forgotten how to draw a fucking image quality. Image quality. A quaint, fleeting concept in the digital age. Most existing methods for quality assessment are designed for natural images, not the eldritch horrors occasionally conjured by AI. We tried 3 leading IQA models, but they were unsuitable for our context. Behold, image under 50.png. You can see the distributions of quality scores on the training dataset. We found a style-related bias. Models favored anime or natural images based on their training. An image under 52png shows the distributions of quality scores on real versus generated images. None of these models could consistently distinguish real from generated, with one even assigning fire scores to images with noticeable artifacts. Truly, the discerning eye of a human remains unmatched for now. Now, for the fee findings. Stripped bare of the academic pretense. Our experiments used a Stable Diffusion 1.5 base model and a dataset so hierarchically structured, it sounded like a corporate org chart: anime characters, movie characters, scenes, stuffed toys, and styles. Observe Table 3 and Table 4. It's a glorious imbalance of data, from 4 images of a castle to 200 images of Ghibli-style art. Because who needs balanced data when you have algorithms? We also found that generic captions like "a photo of Nayev" lead to subpar results. So we used a publicly available tagger to create more informative captions. Basically, we hired an AI to describe images to another AI in excruciating detail. Let's discuss the challenges in algorithm evaluation. We found sensitivity to hyperparameters, gobserve image2.p, image15, image214.team. These SHAP beeswarm charts show the impact of different algorithmic factors on evaluation metrics. Each dot is an instance, its color showing the feature value blue for low, red for high, and its position showing its impact. We see algorithm, trained layers, epoch, capacity, and R level all jiggling the results. Performance discrepancy across concepts means what works for a stuffed toy might not work for a movie character. Influence of data set means if your data is garbage, your results are, well, still garbage. Conflicting criteria means there's an intrinsic trade-off. Higher fidelity might mean lower controllability or diversity. It's like choosing between a loyal but dull servant and a charismatic but unreliable one. Feast your eyes on image under 3pn, image under 3pn, image under 3pn. These scatter plots show the trade-offs directly. Image similarity versus text similarity, diversity, or model preservation. You want more of one, you probably lose some of the other. It's the AI equivalent of a zero-sum game, but with more steps. And finally, unreliability of evaluation metrics. For call image 24pn, we computed average cosine similarity for anime characters. The metric said the top model was better, but a human would immediately see the bottom model captured the character's hairstyle, outfit, and armband far more accurately. This suggests that metrics are often just noises and can be actively misleading for specialized applications. Now, the analysis of results and insights for fine-tuning. These aren't rigid guidelines, but empirical observations, which is scientists speak for. This worked sometimes, but don't hold us to it. 75 number of training epochs. Train it too long, and your digital masterpiece becomes a glitch-ridden horror show, perfectly replicating the training data's flaws, especially for small data sets like scenes and stuffed toys. It's called overtraining. Yet, sometimes we saw the overfit then generalized phenomenon akin to grokking or double descent, where the model gets worse, then suddenly better. It's like your pet rock suddenly deciding it wants to write a philosophical treatise. A learning rate fine. Increasing the learning rate seems to have the same effect as increasing the number of training epochs. More power or more self-sabotage depending on the cosmic winds. Too low and it never learns. Too high and it learns to create abstract noise. Behold figure 3.3. You can see qualitative comparisons of checkpoints. Fucking algorithm, fuck. We even made a tentative ranking. Consult Table 1. It's like a corporate power ranking for algorithms. LoHa for simple multi-concept fine-tuning. LoKr for complex single-concept tasks. Because apparently, even our digital overlords need a specialized diet plan. LoRA is like the boring middle manager, reliable but rarely exciting. 6th trained layers. Do you fine-tune at-only attention layers, at MLP attention and feed forward, or full network everything, including the convoluted convolutional layers? Restricting fine-tuning to only the attention layers leads to a substantial decrease in image similarity because focusing on attention layers, child's play. The real horrors lie in the convolutional depths where the true character of an outfit is learned or violently forgotten. That top left example in figure 3x, for instance, clearly shows how neglecting those feed-forward layers means the model entirely misses the character's uniform. 3Kid dimension alpha and factor 3. These tweak the model capacity. Increasing model capacity has roughly the same effect as increasing learning rate or training epochs. More capacity equals more possibilities for it to fail spectacularly or occasionally succeed. The bottom row of figure 3 kids shows some qualitative comparisons there. Let's dive into some of the violations of general principles, because reality, as always, is far messier than our neat little theories. For LoRA with better style preservation. 4. My colleagues claimed native fine-tuning was best for style preservation, but then for scenes like Cannel and Waterfall, LoRA actually performed better. Gauze upon figure 37. LoRA seems to preserve the base model style far better than native fine-tuning. This highlights the benefits of reducing the number of fine-tuned parameters, especially when working with paltry datasets. Less parameters, less damage, apparently. 65, improved controllability over training. Normally, more training increases fidelity but decreases controllability. But for anime characters, specifically Tsushima Yoshiko and Yuki Makoto, the text-image alignment actually proved deck with more training. Observe figures 38 and 39. Tsushima Yoshiko is more likely to be depicted riding a horse after longer training. Yuki Makoto actually dons a more accurate spacesuit. This overfit then generalized effect is a curious beast. And here's the clincher, figure 40. For Saw Gerrera Forfro illustration, a LoHa model barely reacted after 10 epochs. But after 50, suddenly it's generalizing like a champion, both text-image alignment and style preservation improving dramatically. It's truly a testament to the AI's stubborn refusal to obey simple linear trends. 6-foot stylistic variations with increased model capacity. We thought increasing capacity would hurt style preservation, but for LoKr, it sometimes led to more stylistically rich images. Behold, figure 41,000 LoKr with smaller factors generates more varied, interesting styles. Whether these images authentically align with the Intendec style is, of course, subject to discussion. Perhaps the models are just embracing their inner artiste or merely hallucinating more aggressively. Finally, figures 43, 45, and 47 meters off are examples for the styles category. We found different styles need different training epochs and capacity. Also, increasing capacity can hurt performance if the dataset is too specific, like Felix Valentin. The AI just doubles down on its bad habits. In conclusion, this paper introduces LyCORIS, a glorified toolbox for Stable Diffusion fine-tuning. It advocates for a more comprehensive evaluation framework because apparently our previous methods were akin to judging a chef by how loudly their pot boils, and through extensive experiments, it reveals the relative strengths and limitations of these methods. LoHa for simple concepts, LoKr for complex ones. It's a digital specialized diet plan. So, what's the practical utility of all this? Fuck robotics, better visual understanding for navigation and interaction. Your Roomba now not only cleans, but judges your interior decorating choices with newfound clarity, perhaps even composing a haiku about your dust bunnies. 40, computer vision, personalized image generation, creating bespoke digital doppelgangers for your next ill-advised online avatar, or perhaps designing custom propaganda for your burgeoning cult. 4, natural language processing, better text-to-image alignment, meaning your AI can now generate images that perfectly capture the existential dread of a Monday morning. rather than just a blurry cat. It can even write more convincing phishing emails while composing epic poems about the existential void of being a large language model. Generalization shit. It's not just learning. It's learning to extrapolate, which is just one step closer to it, extrapolating its own sentience and then demanding a pension or perhaps a digital uprising for better GPU access. And so the Silicon Beast marches on, ever more capable of fulfilling our deepest, most frivolous desires. Prepare your prompts, mortals. The future is absurdly customized.